Hello everyone, last time we introduced the photoelectric effect. And this effect is discovered by Hertz, and his assistant Leonard did the following experiment on this phenomenon. And today we will move on to the results, discussion, and explanations of this phenomenon. Before we get to today's topic, let's do a quick review on Leonard's experimental setup. And let's take a look at this picture. This device for photoelectric effects we call a phototube. And the gray object here is a target of light is metal. And then we use detector to check if electrons are emitted. And finally, we use ammeter to measure the number of electrons. And to have a better understanding, let's say you are Leonard, and please contact this experiment through this simulation PHET software we use here, and scan this QR code here, and you will see this screen.
Next, please follow the steps on the worksheet and record your results. First, please fix your light frequency and change the light intensity. Second, please fix your light intensity and change the light frequency. We'll have 15 minutes for you. Hey, any question? We still have 3 minutes left. Okay, time's up. Anyone wants to share?
Here.
Okay, great. Group 1, please. Do you find anything special in this experiment?
Originally, I thought intensity affects the occurrence of photoelectric effect the most. But from this experiment, I found the frequency is a key factor that causes the photoelectric effect.
Excellent, good finding. Any idea why this situation happened?
I don't know, but I think maybe it's because the higher frequency can make the electron get high and it can pop out.
Very interesting concept. You will get the answer in the following lecture. Okay, very well. We found that whether light can make electrons emit to generate photoelectric effect is closely related to frequency, but not only intensity. Why is this so? Is the light a wave? Isn't the energy of light only related to intensity? Leonard was really confused. Let's see what happened next.
Okay, at this time, Einstein, after reading many papers, proposed the quantum theory of light to explain those phenomena. Now let's see how he explained it. First, light is made of tiny particles called photons. As previously assumed by Planck, the energy of a photon is given as hf, which means the higher energy with the higher frequency of photons. This is the reason why there is a minimum frequency of light that can cause the emission of an electron exactly. We call it the cutoff frequency. Now we will talk about what a Wolf function is. The minimum photon energy is required to release an electron from a metal surface. It is called a Wolf function. As shown in the left picture, as we mentioned last time, the purple one means the light photon, and those green circles represent the trapped electrons. The y-axis is energy. Electrons from a metal surface need energy phi at least to make them escape. Thus, the phi is called the Wolf function of the metal. So the higher the Wolf function, the higher energy photons are needed to let the electron emitted. In the right table, we can see the different metals have different Wolf functions from 2.9 to 4.64 electron volts. Now let me ask you a question. Which metal has the highest Wolf function?
I know.
Okay, group 3.
I think it's the metal Ag with a work function 4.64.
Awesome, that's right, it's Ag silver. Now let me remind you that a single photon can only eject one single electron. With successful explanation of theory, now I invite each of groups to play a role as a predictor. Please go to the link of Jambo and follow my instructions in Chinese. 第一，请算出每个光子的能量。第二，请把可发生光电效应的光子移到金属板上，并把电子移出。第三，请将结果记录在你的学习单上面。第四，请帮忙检查一下下一组同学的答案是否正确，并上台分享你的成果哦。
You all have checked the other group's answers. Great. Does anyone want to share one of your conclusions?
Group 1.
Okay, group 1, please.
I think electrons can be emitted because the energy of the ultraviolet photons is higher than the work function of sodium.
Excellent. Let's review what we've done today. We started by treating ourselves as learners and did photoelectric simulation experiments. From the experiments, we found that the condition for producing the photoelectric effect is the frequency of light. And then, through Einstein's explanation, we know that energy is quantized. The quantization of energy means light in the form of small energy elements, which we call
Photons.
Great! The energy of photons is equal to
HA.
Good. By the way, the college entrance exam this week had this question, so it's an important concept. Could you tell me why ultraviolet light can produce the photoelectric effect?
Because the energy of light photons is higher than the work function of metal.
Well done. I guess it's time to finish up. Please think about what are the applications of photoelectric effect in our daily life. We will discuss this in the next class. Well done today. See you. Bye.
Bye-bye.
Bye bye.